Great. Hi there, everyone. So first of all, thank you for joining us today. In terms of the background for this, it's pretty simple. Myself and Anthony at Conjura were doing some work a few months back to try and establish um, what would kind of constitute best practices for doing media mix modeling for fairly simple companies. We saw quite a few examples of long presentations of very sophisticated models for very mature, very complex businesses. And we saw a need in the market for something that was a bit more simple, a bit more practical, a bit more appropriate for people who were just trying to kind of have their first foray into MMM. So here we're going to try and help you get a feel for what are those best practices, how do you avoid making mistakes, what are things to look out for, what are just best tips, with kind of support from a few practitioners as well as a couple of experts moderating the discussion. So in terms of the practitioners who will be sharing their models, we have three today. We'll begin with Anthony from Conjura. He's head of data science at his firm, and he's actually the one who put together the data set that we're using for all this analysis. He'll begin by talking briefly about the data set before diving into his own work. Thereafter, we'll have Carlos, who is an active contributor on GitHub to several MC libraries. After Carlos, we'll have Ted, who has a really interesting background. The thing that really stands out to me is that as a director at Nielsen, he was helping very mature brands optimize ad spends in the hundreds of millions of dollars. Once those three individuals have presented their work, we will have two experts leading a discussion of what was presented. One is Jim, who is the organizer of MMM Hub, which, as of last count, had over 400 active members. It is the largest media mix community, at least I'm aware of. And the other is Michael from Recast. He's a co-founder at Recast, as well as the author of what is arguably the most widely followed and most highly regarded newsletter in the space. So I would highly recommend that you guys subscribe to it if you aren't already. One thing I would add is that for us, the hope is that this will be just the first in a series of conversations. Here, we're trying to establish the platform for building models in the space. Next step from here will be applying these best practices to build models simultaneously for dozens and hopefully hundreds of companies, and start building some insight around just how wrong, let's say, for example, platform reported CACs are for Meta, for Google, how wrong last touch CACs might be, how they compare across different kinds of brands, what instances where MMM tends to break down, just building some meta intelligence, which has so far, from what I've seen, been missing in this community. And if you're interested in that, do please look out for an email follow-up in the back of this webinar, and we'd love to have you participate in that research. But with that said, I'll pass it on to Anthony, who will talk about the data set using this analysis, and also will present his own work. Anthony, hi there.
Hi, thanks, Alexi. Yeah, so we now have an open access data set. This was put together by my team, the Conjura, but the really extensive data set, we're approaching 100 brands here, and we're going to share a link here afterwards in the follow-up email. You can all really jam on this and start contributing and get involved in this project. So I guess where does the data come from? I might briefly say, so really this Conjura, we have built an analytics platform for e-commerce businesses. Ingesting and transforming the data for the business is really kind of our bread and butter, and we offer a number of analytics kind of products off the back of that. We work with agency and investor partners to do kind of deep dive e-assessments with competitor benchmarking, and we also work with brands on an ongoing basis to optimize their marketing, inventory, customer bases with sort of a major focus on profitability. So we have a lot of data. This is a relatively small slice, really focused on MMM and the requirements there. So I might just hop over to. I just want to give you a general sense of what's in the data, just so you have more context. Ted, Carlos, and myself have been what we'll present is really based on a small sample of this data. So you can kind of see what kind of assumptions we're kind of leading with. Whoops. So in on Figshare there, which is the site where we're hosting the data set, there's a data dictionary, and really this kind of just goes through in detail what we have. So I'll go through this really quickly. And in fact, I'm going to try to go relatively quickly all the way through, just so we can actually get to the discussion part. But let me start with what we have here. So like I said, we're approaching 100 organizations, which we've anonymized in this data set. So this organization ID really marks that brand. And then we have details about each brand. So what's their top level product category, the vertical, the sub vertical. We also have the sort of primary market that they operate in. We are focused for this project, and for really all the brands we're looking at. These are brands that are really utilizing kind of three main marketing sources: Google, Facebook, Meta, and TikTok. So these are the primary sources. You'll see which ones are activated by those brands in this field here. And then in some cases, a brand might operate in multiple territories. And if we have sufficient data in those multiple territories, we may have territory level splits for that brand as well. So there's a lot here. It's probably worth saying the data is at a daily level granularity, and we're able to get a view of really first purchases. This has really been a focus, I think, of Alexi and ours. We really want to investigate CAC. So first purchases in here. We have information about price and discount on first purchase. And then I guess if you're interested in more of like a ROAS type of approach, you can see all purchases. And then on the marketing side, we have the daily level spend. And so for each of the marketing sources I described, we've split those out further. So you can kind of see sub channels within, so paid search, shopping, performance max for Google, for example. For Meta, Facebook, Instagram, and then TikTok kind of stands on its own. Now for these paid channels, we have a view of clicks and impressions generated by that spend. And then for all other channels, we have traffic measurement down here at a daily level. So there's a lot here. There's plenty to work with. And I think quality-wise, we've done a lot of work to ensure this is sort of a high-quality data set. And as we get more brands that sort of fit the bill, we may update this data set. And so Figshare is kind of great. We can version control on that and kind of release changes. So without further ado, let me get into sort of, I guess, what I'm sort of trying to focus on here. And what I want to kind of, what I'm looking for feedback from this panel. I think, so I'm really motivated by this question. So what is a robust model formulation for estimating CACs? As Alexi pointed out, like I'm really interested in, okay, ultimately I'd like to use estimates from a marketing mix model to really compare against, the traditional click-based and marketing platform-based measurements of CAC. And I think it's a really useful exercise, I think, for brands, for everyone who's sort of concerned with the state of attribution today. I haven't seen a lot of quantitative comparisons of these two. So I think this is having a robust marketing mix model really gives us a way to kind of bring in MMM measurement in sort of a benchmarking capacity. Now, we are at arm's length from all of the brands here, right? And I think we should take for granted a certain amount of uncertainty, right? We can't go and validate certain things about the data. And I think it's for this reason that Bayesian approaches are kind of ideal, where we can really quantify that uncertainty and take that into account. Um, it also provides a lot of ways to formulate and kind of capture our domain knowledge. And there's a lot of great work out there. Google and other people, MMM Hub, talk a lot about it. PyMC open source libraries are sort of bringing some of the tried and true formulations over. But just as a starter, there's so many choices you have to still make. About linearity, non-linearity. If you want to look at ad stock or saturation, are my marketing coefficients static or time varying? What about trend seasonality? There's a lot of decisions that still have to be made. So, what's an ideal starting point? Well, if you were working with a brand directly and had access to a marketing team and even better experimental results, no doubt you would use those to drive those decision makings. While we don't have access to those here, we do have the opportunity to test in aggregate across 100 brands. And so with that in mind, I guess what finding a model for me, and really what I want to focus on, and I think it's really foundational to everything that might stem from this work, is really what does a scalable and reproducible validation procedure look like so that we can find such a model. So the way I kind of have four kind of main pieces I'm looking at, and I'll try to get through the rest of this really quickly. I want to focus on the last two. You'll be familiar with these validation approaches. Obviously, with Bayesian modeling, convergence and parameter recovery are quite key. These are kind of part of the best practices in Bayesian workflows. We should use out-of-sample data. We have plenty to do that to test predictive performance. But in thinking about what is a generally good model, we kind of want to look at how does that performance look across multiple brands. So how do we aggregate that to sort of find a leaderboard amongst all possible formulations? And because ultimately we care about the marketing contributions and the measurement of marketing, we would like to inform this in some way by how causally difficult or how well we think that prediction is doing on the marketing variables themselves. So I want to focus on the last two, though I'm sure we may get into the first two in follow-on discussions, because they're certainly important. But I think the last two are a bit more novel for this project. So I'll step through an approach. At least this is an approach as I see it. And I'm going to do this really quickly just to present the main ideas. So we have our data, and we would, for a particular brand, let's say we've chosen our formulation and specified priors. And then for any one brand, we'll set aside a holdout here in orange. We'll train on the rest and then measure our out-of-sample performance on the holdout data. So we'll get this sort of performance measure. Now, one way to think about the causal difficulty is, well, let's compare the marketing allocation in our holdout period. So how is the budget or some other measure sort of divided amongst our channels in the holdout? And how does that compare to related time periods? So kind of the dark gray. And if we compare those two allocations, we can kind of say, at least directionally, how difficult is it to make the prediction in the holdout set based on precedence. So if we kind of take that approach, we'll get a measure of difficulty, and then we can kind of rinse and repeat on all the brands in our data set and roll up these out-of-sample performances and take into account the difficulty measure here, and sort of create this sort of weighted aggregation. And so for each formulation, then we have a sort of a single number that we can sort of begin to form a leaderboard with. So that's the idea, and I'd definitely like to get some feedback on there. There's a lot of nuance in here, obviously, but my time is up. I'm going to hand it over to Carlos.
Yeah.
Thank you,
Really,
Anthony.
Yep. I just wanted to say that really thank you, Alexei. Really thank you, Anthony, to put this together. I will share my screen quickly. I think that I also start to, when I first see the data set, like Anthony, I was having thoughts about like what is the best way to approach it and what is the best way to generalize the process that we are building here for several companies, understanding that we don't have like these connections with marketing teams, and we can start to like get their input around like how certain channels are working. But we definitely have, and at least in my case, this is something that we actually practice with PyMC as well. We have mechanisms to test what is the causal what are the causal dynamics that are affecting our data. So one of the practices that I actually wanted to show in these 5 minutes is, for me, even before I start to compare models or even start to build your model, you need to establish what are the assumptions that you are having behind that model, and just make it like very transparent. And we can use DAX in order to do that. So if you're not familiarized with DAX, for me, it's just the way that we can express reality and understand how variables are interacting. And once you understand how those variables are interacting, then you can, in your model, basically define which features you need to control for those interactions, or which components you need to add into your regression, because by the end of the day, all of the MMN models are regressions, which are needed in order to control that interaction. And once as well you have the DAG, you can start to actually test it. You can put this DAG to test with, I don't know, refutation tests or falsification tests, and see if actually this conception of reality that you are putting in your head makes sense. So if we just find, that's how I see it, if we find a DAG that can represent the reality of the brand, then we are halfway path. We can actually even have maybe not a so complex model, but if the model have the right characteristic to explain what is happening, then the final estimate should be still like close to reality, or at least that's what I have been seeing, or at least closer to reality, that when we don't consider it at all. So yeah, by the end of the day, the first thing that I start is just building this DAG, where I ask myself like how for example, seasonality effects, marketing effects, and other effects that I cannot control or I don't have in my data set, how those impact my target variable, in this case, the sales or the number of new clients, but to be honest. And then I just define that, okay, this is the DAG that I really like. And I had another complete notebook where I basically just went through this DAG, as I mentioned, through the refutation test or the falsification test, and put it to test. I didn't add it here because it's like very long. But by the end of the day, once you define this DAG, I just left the code here so you can check it. You can just do Y to do that. So once you find the DAG that it's following all of these criteria, then you can actually decide which feature should go into your model. And then from there, you can have a more trustworthy estimation about like your final outcome in general. So that's a bit more the way that I start to approach it. So I really wanted to understand this causal reasoning behind our target variable. And the second thing I wanted to just add is the time component. So one thing that we usually neglect when we are doing these models is understand how, for example, impressions varies over time. And in that sense, a very easy framework that I'm working on it, it's we have for certain, we know how much we spend, we know how much impressions we are getting back for in each platform, and then we can estimate basically how that variation, how that year that I spend, how many impressions give me back in a certain period. I can estimate that variation, and then if I train my model in impression level, then I can after that apply that variation to transform it to spend. So now I can know that at certain level of spend, I will get certain level of response in a certain point in time. And that's very helpful because by the end of the day, you end up with this same response curve, but time-based response curve by the end of the day. So in this a small example, I was just showing that if you spend the same 20K in Google, for example, PMax in February, you will get, I don't know, 17 new users. But if you do the same in June, then maybe you get like, I don't know, 15, something around it. And that difference is basically just effect of time. So yeah, that's I would say my focus. So what I wanted to say is that if you have these two controls, if you're controlling the real causal effect behind your marketing, what is the causal graph that is behind your marketing effects, and you also understand that variability can be affecting, and you have a framework to control these two, I believe that you will be close to reality, even if you don't go to complex models. I also did the play about like how this changed with different models. I'm not sure if I have the time. I just will quickly,
I think you might be a little out of time at this point. Nearing the end of time. What I actually will say here is, I think for both you and Anthony, we're trying to keep this very, very snappy. So clearly, 5 minutes isn't enough to do justice to the work you've done. Would it be okay with you if we shared the white paper you put together afterwards with attendees?
Sure.
Just so they can go through themselves. Fantastic. I think that should be really helpful, and it seems to be well annotated, so it should be perfect. Thank you, Carlos. Nice. That's perfect. And yeah, switching over to Ted.
Hi, Ted. Guys. Thank you. And I do want to say thank you again to Alexi and Anthony for putting together both this project and the data set, especially. My situation is a little different from both Anthony and Carlos in that I came to this project when I was looking at maybe needing to do some independent consulting with marketing mix. And I come in and say, well, I'm already an expert. I don't need any causal modeling. I know what the causal structure is. And more to the point, I'm focused on very specifically how to rapidly get advice on where to spend your next marketing dollar when you're already marketing. So my concern was really, could I build a custom software package that I could use for myself that would rapidly build not stupid MMMs? And the answer is not in the 4 weeks I took to do that before I went and got a day job. So where I landed is I sort of abused the offer to take all this data and built a quick R package that attempts to find the best regression model, ignoring several causal questions for marketing budget allocation. And what I've got up on the screen here is some examples of why it still needs some work, basically. So here, this org, you can see it's got a takeoff in volume and new customer acquisition, which is fantastic. You can see my model missed maybe some key activity in here. Maybe that's marketing, maybe it's not. What would be ideal from an analyst's point of view, from a usability point of view, is if we could be real sure why the model missed this without having to do a lot of deep dive work. And right now, I don't have an answer for that. That's the answer I would like to get to. So I'm going to see if I can scroll over here. All right, so I've got five organization IDs from Anthony's data set in here. This is the volume decomposition or new customer decomposition that's associated with the fit chart above. You can see it's nice. It's got marketing activity in here. Maybe it's hard. These colors are bad, but this says that spike, that huge increase is a lot of it's due to marketing, not search though, dear Lord. But then you get some more problematic cases, right? So here's a lovely example. Again, red is actual new customer acquisition. Blue is what I'm predicting. My model identification was terrible here. A lot of possible reasons for that. To me right now, this looks like I need multiplicative seasonality and I don't have it. But again, ideally, I'd be able to build a package that would find that for me, right? So I'm going to scroll through this just a little bit, but obviously you guys can have access to all these details after the webinar. You don't need to watch me scroll. As a fun example though, why would my model pick a negative trend for this? Anyone have any ideas? My guess is marketing spend's increasing, and I've got those lovely Bayesian priors, and it's pushing a negative trend in to get marketing contributions in. But those are the sorts of deals, things I'm worried about. That's the sort of problem I'm trying to solve. And again, I'm just thankful to have a data set to try it all on. Alexi, I know I took less than the allocated 5 minutes, but that's good. Well, that's what I got.
That's perfect. Actually, Jim Michael, if you don't mind, I'm going to bring Anthony back on just to show the actual models he's built. I think he did a very good job talking about the framework he's looking to build. But I think just while Ted, was able to go right in the weeds on the actual model he built, I think having a similar kind of presentation, I think might be helpful. Is that okay? Perfect. In that case, Anthony, you are on.
Yeah, I wasn't planning to dig into this because I think it's quite dense. Because I suppose so I did some experiments and I think the data has actually evolved a bit since this, but really I wanted to kind of run several different, like kind of this idea of like really running a lot of different formulations against multiple organizations, looking at different granularities, looking at different likelihoods, different types of channel transformation, this being sort of a linear model, different types of control variables, seasonality, etc. So I kind of ran this big matrix against 4 brands here and kind of found some interesting things. And this kind of informs, I guess, the way I've been thinking about really how do I even select a model? Like out of all of these possibilities, which one should rise to the top? And I'll just highlight that challenge here. So this is, you can see there's several on the left. Each row here is a different combination of those modeling choices I had described before. And, I looked at, was there convergence issues? That's the sort of first green, and generally that it wasn't for this first model. We did have some divergence issues in one case. But then, and this is, by the way, this is a completely horrible measure of performance for a time series model. This is leave one out log likelihood, which is almost certainly overestimating the actual performance on out of sample data. We really want to leave future out. So really want to either do kind of a different type of cross validation or do the hold outside I was proposing. We get situations like this where there's on a surface, these models look all like they're performing generally pretty well. But I really wonder in these cases, and this is what I want to discuss, it's, the models that do well are the ones that I have the most control variables set in, either for seasonality and all, lots of different, and I think that really takes away from the point of the modeling, which is really to estimate the marketing parameters. So seasonality is one where, if I add seasonality, here's an example of, take these top 3. If I add seasonality, I really pull all of that marketing performance away from the channels. And so this is sort of, these blue bars are sort of a measure of the CAC I'm estimating, and you can see it's wildly different depending on just simply adding or removing seasonality. So I think this is where I've kind of come out of this thinking, need a better way to measure performance, and ideally one that really incorporates the kind of causal or the marketing part of it. Is the marketing in the holdout period actually going to be difficult to measure given what I've seen in my training period? So I'm happy to share this afterwards if anyone wants to dig in deeper. But I felt this was V1, and kind of out of this, I kind of wanted to reimagine my approach to validation. So I'll leave it there. Thanks.
I think that really gets the heart of the issue that you and I were trying to solve. You can just throw dozens of models at a backtesting engine and kind of see which one spit out as the best one, but that doesn't seem like the most sophisticated. Doesn't seem like the right way to do it. So yeah, now tell us how to actually do it all right. Jim, Michael, no pressure, but
well, you know, they say the best thing to do is to find yourself in a room where you're the dumbest one in the room, because everyone else is smarter and you can learn from them. And I feel like I definitely fit the bill today with that. So yeah, thanks for having us on to provide our expertise.
Yeah, look, first of all, thanks for having us. This was awesome, amazing work from the modelers. All of them, I think, did some really interesting work under a pretty tight time crunch. So very excited to chat through that. For the listeners today, run of show, Jim and I are going to have a little bit of a discussion here about some of the themes that we saw that we think are particularly interesting, relevant to MMM, and then we'll transition and have sort of ask all of these different modelers questions. And if y'all have particular questions in the comments, there's already a lot of great discussion happening. Drop them in so that we can, potentially feed them to these different modelers that just gave their little presentations. But I guess to start, Jim, we just saw 3 different modeling approaches today. 3 quite different modeling approaches. I mean, people put different emphasis on different parts of it. But I guess one question that I spend a lot of time thinking about in this world is like, how do we know which approach is right? I'm sort of assuming, right, that like if we actually looked at the incrementality estimates from each of those 3 different models that came out, we'd probably get sort of 3 different results, depending on the different assumptions that were made by each modeler. So how should we think about knowing which of those results to trust or validating these models?
Yeah, who was it? George Box, who said all models are wrong, but some are useful, right? And that's an applicable quote for this, is that, and you'll see this, anyone who's done MMM for a while and has done many models on the same data set will know that, like, why did all of a sudden the ROI of Facebook completely change in this model from the previous model, but the normalized root mean squared error is the same. So yeah, I mean, trying to figure out which model is more useful than the others, or which one is kind of pointing in the right direction is critical. And I think the things that people generally do, right, we'll look at some statistical measures like R squared. Obviously we want to look beyond just that, but just getting a sense of how the model is performing, looking at things like R squared, looking at root mean squared error, how some of those goodness of fit measures, but then kind of going beyond that and really understanding, is this model capturing the underlying data creation patterns? We can do things like incorporate geolift experiments to test to see, like, okay, the model says it's, has a 2.3 ROI, and let's test that and see how that validates or doesn't validate the model. But then ultimately, I think we get to a point where, and this is something I know you're, you talk a lot about, which is sort of the validation and from the perspective of out of sample forecasting, and how well is the model able to predict something that's going to happen on data that hasn't seen yet. I know that can be a little bit of a challenging prospect. So maybe you can talk a little bit about, and I know Anthony talked a lot about out of sample accuracy as well, but maybe you can talk about what some of the practical challenges are of doing that and doing that well.
Yeah, I mean, Anthony did a really great job of highlighting what I think some of the challenges are with how to think about this. So first of all, he noted that, like, if you do leave one out cross validation, which is common in a lot of like machine learning libraries, it's not actually measuring the right thing, because we have time series data. And so if you're testing any one point, but you have the points on either side, you actually have too much information for doing the right type of challenge that we're looking at. And so out of sample forecasting is quite hard. There's problems with like information leakage. Again, I think a couple people talking about that in the chat, that you have to be really careful about. And then you also want to understand the difficulty of the problem. And again, Anthony did some amazing work here on trying to think through, how do we think about how difficult is the forecasting problem? Because if the period that we're forecasting looks just like the periods before it, then it's a really easy forecasting problem, and we can forecast it well without actually having gotten the causal relationships estimated correctly. What you really want to do in order to demonstrate that you have picked up those true underlying causal signals is you want to forecast when the inputs are changing. And so if you have a model that can correctly make a forecast when YouTube is really high and Facebook is really low, and vice versa, and when we, cut out all of our branded search, if it correctly forecasts in all of those periods where your inputs are moving around a lot, that gives you a lot of confidence that you've picked up that true underlying causal signal, and is a great way to think about validating it. It's a lot easier to do out of sample forecasting if everything stays flat, right? If you always spend the same amount on Facebook and you always spend the same amount on TV, then your inputs aren't changing. And therefore, just being able to get a correct out of sample prediction doesn't tell you that much about whether or not, it doesn't help you falsify, right? Whether or not you've actually picked up those true underlying causal signals. The other things that we talk a lot about outside of just, out of sample accuracy are validating with experimental results, right? This was a thing that I think all of the modelers mentioned as being like, oh, well, we don't have any experimental results. So it's like, we're really doing this in a place where we don't have a lot of ground truth to compare to. And then also just thinking about, one of the things that I like about MMM is that in general, and this is not the case in this particular exercise, but in general, we're working with marketers who actually have their hands on the controls. And so you can tell them like, hey, the model is saying this channel's good, go put more spend into that channel, and that helps us validate it. So you can do these sort of proactive quasi experiments in a way that can give you a lot of signal as to, hey, did we actually pick up the causal relationship, and can we use that for making decisions?
Yeah, exactly. Like not everything has to be randomized controlled trial, right? We can just make some changes and see how well the model picks up on that. Yeah.
Yeah, I think that's right. One of the other things, that people talked about here a little bit was, first of all, different modeling approaches, whether you're going Bayesian or sort of other more straightforward regression type approaches, and then also the different assumptions that were being made. I'm curious, how do you think about the trade-offs between, Bayesian approaches and non-Bayesian approaches? And then also, how do you think about uncertainty quantification and the analyst degrees of freedom that go into building these models?
Yeah, I think, surprisingly we didn't, and maybe it's probably for the better, we didn't go into this whole Bayesian versus frequentist debate, which is probably not worth wasting our breath on. But, it's sort of a real question as people, thinking about it from someone who's new to MMM and trying to dip their toes into it and getting started in it. I think there's a decision that you kind of need to make. If I'm as an analyst trying to get into this, am I using R or Python? Am I using Robin or Lightweight or PyMC, or am I just building it from scratch? And I feel like from a beginner's perspective, I'm just going to say it and see if you disagree with me. I would say start with Robin if you're a beginner. Unless maybe you have a really strong background, your master's in statistics or a mathematical degree. I think that's probably easier to get started with and easier to get kind of up and running. But certainly I think, Bayesian probably has some significant advantages in a lot of other areas in terms of kind of more accurately reflecting sort of the reality with the DAGs, I think it was Carlos was showing the way you can kind of more accurately represent what's really, our sense of what's happening in the marketing world. And then looking at, from the uncertainty perspective, looking at the credible intervals, which I feel is a better way of capturing and communicating that uncertainty that the model has in the various channels versus, you can use confidence intervals and the other approaches, but it's just a little bit different and probably not as useful.
Yeah, so I think, if you're really truly new to this and you just want to get your feet wet, start to learn about what media mix models do, I think Robin is a good place to start. But the thing that I don't like, there's a couple of things that I don't like about Robin, especially for beginners, because I think it doesn't always promote like truly best practices. And so one of them is that like the holdout testing in Robin isn't true holdout testing. There's information leakage that is happening there between basically the way the seasonality and the time series components are estimated and the way the rest of the model is built that makes it so that the holdout accuracy numbers aren't actually correct, right? And so like that is like, ooh, it's in the weeds, but if you don't really know what you're doing, that can lead you astray. And then additionally, one thing that I've heard from people who are starting with Robin is like, okay, it's really cool. And you run Robin and what Robin will produce is a whole bunch of different candidate models that are along this like curve between the different variables that it's optimizing towards. And so you get like 30 models out. And then analysts are like, well, what do I do now? Like model A says one thing and then model Z says something totally different. And I guess I could just choose one. But like at that point, like if I really model it, like, is that best practice? And like the answer is no. But so those sorts of things, I think, are places where if you're really new and you don't have like a good theoretical framework for evaluating these different model classes, a tool like Robin, again, really cool, really powerful tool. But like in the interest of making it easy to use, they sort of hide some of the complexity that I think is actually really important to deal with when you're going to actually use these results to go make hundreds of thousands, millions of dollars worth of budgeting decisions.
Absolutely. I see.
So,
yeah. Okay. Go ahead. I was going to say. So one of the things, kind of last point here, and I think we'll start to get into asking some questions of the modelers. We're definitely leap years beyond leap years. Didn't mean that ironically. We're far removed ahead of the times when you would build a model for the past year and you do this exercise maybe once a year, twice a year. Like we're building models a lot more quickly now. We're updating them with monthly or weekly data. And I know you're a huge fan of this and you've talked a lot about this as far as sort of this high velocity or agile MMM. So talk a little bit maybe about what that means to you and how does that fit into kind of what we've seen today in terms of the data set, in terms of the choices people are making in the modeling and how that plays out.
Yeah, so I mean, one of the things that I was really excited about with what we saw today is sort of everyone was taking this like software first approach, which is what's cool about this open source data set that the team at Conjura is making available, which is that there's so many models to build that if you have to like hand tune every single one of them, you'd never be able to work with it. And so it opens up this idea of being like, how do we do this in an automated way in bulk, but then still get good results, which I think is the really hard part about it. I talk a lot about, high velocity MMM of like doing this frequently for a couple of reasons, because I think it opens up more actionability as one, right? So the nice thing is if you're refreshing this model constantly, you're constantly getting updated signal as to like, what should we actually do as a marketing team next month? If you're only refreshing the model every 6 months, things might be changing on the ground in terms of the products that you have, in terms of what's going on with competitor activity. And that means that like, what I've heard from marketers, right, is they're like, oh yeah, we got these model results 6 months ago and they were trained on data from last year, but like, I don't feel like I can use them because this year's different. And then, they say that a lot. And so being able to update these things frequently, I think makes the results a lot more actionable. Additionally, even beyond that, it actually makes the results more validatable. Because if you can run these models really frequently, you can better match the timing of when the model is estimated to when a lift test is being run. And so you can like train the model up to just before the lift test is run, compare the model results with the lift test in a time period that should be relatively comparable. So that's like a very powerful thing to do. It also opens up this idea of this like prospective quasi-experimental evaluation of saying like, hey, we estimated the model through yesterday. It says we should spend more on YouTube. Let's make that YouTube budget change, increase it for the next 3 weeks. And then we have a falsifiable prediction that we can compare to. Did revenue increase along the lines of what the model forecasted or not based on those results? And so this ability to do things very quickly and move fast opens up a lot of possibility for more validation and more action being taken off of the model itself.
Yeah, and of course, as noted in the comments, a big factor into how frequently you can run the model is how quickly you can get the data. Some companies have really nice, clean marketing data warehouses that are getting data fed into them daily. Others, not so much. So gotta get your house in order first with the data side. But yeah, for sure. So yeah, I think we're ready to open it up to questions, maybe talk with the modelers again and ask them some questions about their decisions that they made, and get some questions from some folks on the who are attending.
Yeah, that sounds great. Alexi, you wanna bring in our three modeling panelists here? Okay, amazing. Thanks, Carlos, Anthony, Ted. Really impressive stuff that y'all made. Very, very exciting. Anthony, I mean, you spent a bunch of time talking about or thinking through this idea of difficulty and out of sample prediction. You know, we had some questions in the chat that I saw about like exactly how your difficulty measure was made and how you think about that. I also posted some comments about how we think about it at Recast. Maybe you want to do a quick overview on like, what are you trying to get at with difficulty? Maybe a little bit more detail on exactly how you were constructing that method, that measure.
Yeah, that's fair. I was gonna, for some reason my slides disappeared. Yeah, so I was thinking of it in two ways. Sorry, it's blank. My slides will not show up. So I think, you know, if our holdout period is sort of at the end, let's say we hold out like 4 weeks, right? Because of, I guess, presumed seasonality or kind of, you know, near term behavior, like I was thinking of this, okay, so let's say we understood how the spend was allocated across all the channels we're measuring in our holdout period. So we kind of have, you know, percent spend by channel. One way to do that is actually take two comparison periods. I was thinking of, you know, the most recent 4 weeks and perhaps a 4-week period from the previous year as useful comparison periods to handle seasonality a little bit. So if I then look at the budget allocation of the channels in that period, again by percent, I can compare the holdout to those comparison periods using something like cosine distance, right? And so obviously the higher the distance, the more dissimilar your holdout spend is to your, you know, the relevant comparison periods. And therefore you could, if you were going to roll up that performance, you would want to sort of emphasize good performance on that one brand in the sort of aggregate measure. That's sort of the main idea. Obviously, this is totally faking causality, but like it is a way to try to address the actual marketing measurement.
I love it.
And thanks for sharing your formula. I'm pretty sure this idea was incepted by yourself, Michael. So
I don't think we have. This is one of those things. Like, this isn't proprietary. It's just I was in our Slack internally when you were talking about it. I was like, "What's our actual formula?" Because I couldn't remember how we did it. And anyways, it's there. It's like that's what we do. It's not super sophisticated, but at least gives you this sense of like, is it harder or is it easier? And then that's useful for scoring yourself internally to say like, how are we actually?
Yeah, and I was just seeing this case where like, yeah, sure, I can get great performance when I put control variables in, right? And like, I wasn't doing a great out of sample assessment, but to me, it's just like, look, I need some way to penalize essentially overfitting the data or over controlling for things that really are part of the marketing. So this is the sort of idea, is just how do I do that and just like give that enough weight in the grand scheme.
So there's, I'm going to switch topics now. There's been some questions in the chat about like validating. I mentioned this, like validating with lift tests, validating with experiments. There's been a bunch of chatter on LinkedIn recently for the nerds who are like deep in that about this idea. I'm curious to get y'all's thoughts about it on it. I know that I think some of y'all had mentioned this in your talks or mentioned it in the abstracts about, you know, not having tests to work with. Ted, I know that you have opinions here, so maybe I'll kick it to you first. Like, I think what would you recommend to the audience here in terms of how to think about incorporating experimental evidence into this modeling practice?
Yeah. Okay. So let me say that in this context where we don't get to talk to the marketers, it's going to be impossible, right? Unless they happen to run one for us already. But I think in a general way, when one is working with marketers directly, we should be able to say, look, guys, we really want to know if we're giving you the right advice, so you should test it. And just like you and Jim were talking about earlier, the thing is, you don't have to design carefully an experiment. You can just say, hey, I said you should increase your spend on this Facebook remarketing 10%. Can you please do that? And we'll see if it works, right? It doesn't have to be complicated. But I do personally think that there's some idealized world where the marketing team sits down and says, we need perfect measurement, and we're going to build a complicated designed experiment across many geographies and test all of our channels in a way where in the experimental design, they're not confounded. And then we'll fit the regression model to that data. And then we'll have this lovely response surface for modeling or marketing. I've never seen that happen. I don't know if it can happen. It's expensive. It's hard. But I would love to see it happen. So if anyone knows a marketer that wants to try something expensive and hard, send them to me.
That's awesome. So I know one of the questions that has come up both in questions when people signed up for the event and in the comments here are around the variables that we choose to include, and especially questions around like how many, Anthony, you mentioned, I can get better performance just by adding more control variables. So I guess my question is, and since we haven't heard from Carlos yet, I'll ask you, Carlos, kind of a two-part question. So one is, how do you deal with situations where you just have a lot of different independent variables? And maybe that's because you actually are spending in a lot of different areas, or maybe it's because you've segmented a channel into like you've segmented paid search into PMAX and Google branded and non-branded and remarketing and prospecting and all of the other different tactics that you're using. So I'll pause there. I'll just ask the one question. So how would you deal with having a lot of variables?
Totally. I will say I try to think if I can actually group all of those variables into a same node that interact in the same way. So for example, if you ask me like how PMAX and Google like shopping campaigns are like impacting our users, I would say that maybe both are actually like maybe upper funnel activity where users go to search or they find us at some point and then they maybe will find us again in Facebook or whatever. So if I maybe can group those to reduce the number of independent variables that I have in my data set, I will try to do it if that combination at the same time makes sense with the underlying structure that I'm having in my DAG. So that's how I will start to reduce the number of variables that I have, because otherwise we will have the problem of a data set with thousands of variables, like over parameterized because you're estimating a lot of different betas or whatever, and that's a problem basically. But that will be my way, I will say.
Absolutely. On one more question, and I'll just throw this out to the group on still related to sort of the marketing data and the channels that you choose to include and how you deal with them. The data set that we're working on was fairly straightforward, right? We have Google, Meta, TikTok. What happens when we throw in affiliates and influencers and billboards and TV and some of these sort of, channels that don't necessarily play well together?
Yeah, totally. I mean, that's why, and sorry, I just want also to bring this topic. One of the things that Anthony was mentioning is like, when I add some certain control like factors, then my regression changed totally, like the values that I'm estimating for the channels as well change. And that's actually why I really like this causal reasoning, where we start from define like how these variables interact, because that actually gives you this consistency across different like parameterizations. Actually, one of the things that you can do with DoY is this falsification test, where they in purpose take your regression and they switch the nodes and they switch the variables and they see if the estimated effect, the estimated treatment effect they are ingesting like in fake, it's actually making consistent your your prediction is still consistent even with these like placebos. So that's something that it's like very nice, and that's why I actually try to start from the causal part, so I could be actually kind of sure in the absence of experiments and marketers about what I'm estimating, and whatever I'm estimating is consistent. So if I start to add this TV, radio, or whatever in my DAG, and once I do this permutation of my DAG, and when I do this like test, falsification test or refutation test with my DAG, and I see that add those variables is actually like hurting my model, making my estimations less consistent, I will actually say that let's go to the point where we model the things that we can, and we evaluate those channels maybe through pure experiments, instead of actually bring those channels into my model, and all the estimates around. That's what I will say. So, and that actually comes with the question of, if you are trying to just understand like the impact of the channel, you not necessarily need a model, or you don't need it in a model. You can actually still estimate the impact of the channel using experiments, right? I mean, that's my way to see it. It's an open question, and I would love to hear like the debate here.
I like that way of thinking about it, and it kind of goes back to the idea that there is no silver bullet here, right? You know, I think marketers, maybe especially digital marketers, for the past decade or so have been, you know, kind of, we've been lazy, and we've been just saying that, oh, multi-touch attribution, that's the only thing I need, and really, yeah, there's no one answer, one silver bullet that can do it, right? We need to use MMM and corroborate with experiments for channels that don't quite fit nicely into the MMM, or use other ways, use surveys, use other attribution methodologies. Yeah.
Jim, I might just jump in on that on variables. I suppose I made a really conscious choice to leave affiliate spend out of the data set, because it is just a leaky variable, and I don't want anybody to get tripped up on that. I mean, you can track affiliate traffic, but the spend is left out. I did the same with branded search, right? Because this is really just loading demand, right? And it's just the sort of Google tax. It's sort of not really spend to drive marketing. Though one thing I've really struggled with, and I saw this in a couple examples, is because I did have the context. I knew there was a brand a celebrity wore their gear, and they just got this huge, bit of organic traffic. And I was never really sure how best to take that into account. It wasn't really intentional marketing, but it did drive a lot of organic, and I didn't want that to bias the results. So I struggled with the best way to kind of control it for that kind of thing when it occasionally happens. So influencer like stuff and that mishmash is tough, right?
Absolutely.
So I think we're about out of time. I just want to be mindful. Alexi, I don't know if you wanted to come in and give the final words here.
Sure. I mean, I think there are quite a few questions. I mean, Kaminsky spent another hour going over the questions and comments that have been posted in the chat here. I think what may be the best way to take this forward is to use the MMM Slack. So again, Jim, thank you so much for organizing that, having the community going. And yeah, as mentioned at the very beginning, insofar as anybody on this call right now is interested in becoming involved in this research and actually helping, again, advance this, helping us work towards establishing kind of a common best-in-class model for this, portfolio of 100 brands, please just let us know. Shoot me an email afterwards, and we would love to have you involved in this work. But yeah, for now, I'll just say is Jim, Michael, Anthony, Carlos, thank you so much for making this discussion possible. Anthony, thank you to you and Conjura for making the data set available. And yeah, I think it's abundantly clear that this is a very deep rabbit hole, but I think it's really one to explore it, because at the end of the day, this can have massive repercussions, as kind of like to put it, to operators, smaller brands, not just for improving the performance of your ad campaigns, but only for ensuring the success of your business and avoiding failure by extension. So yeah, really cool stuff. And I'm personally really excited to keep working on this with you guys. Thank you so much for your time. And thank you everyone who dialed in to
Thanks, Lexi. Thanks, guys.
Thanks, everyone.
Thanks, everyone. It was great meeting y'all. Great discussion. Really loved it.
Bye, guys.
Cheers, guys.
Thanks, everyone. Bye.